Powers of monomials. First, we need to remember what a monomial is. And if we refer back to that definition, it's just simply numbers or variables or numbers and variables put together. Now, when we're taking a power to a power and talking about that property, an example would be parentheses a to the m power, close parentheses, to the n power. All that's saying is that we take everything inside those parentheses to the n power, including the power of m. What that looks like is a to the m times n, which is a to the mn. Now use an example with some numbers to kind of visualize this. If we had 7 to the 4th power all to the 2nd power, that would be the same as 7 to the 4 times 2 power, which is 7 to the 8th power. Now if the question is asking you to write it as a power or using exponents, then you're going to leave that number as it is. You're not going to evaluate it. Because if we recall, the word evaluate tells us to find the value. Now, if we're looking at the example, n to the 3rd power all to the 5th power, that would be n to the 3 times 5, which is n to the 15th power. When we're given a number that has a negative exponent involved, like 2 to the 3rd power all to the negative 2 power, we would do 2 to the 3 times negative 2 power. Now notice how the 2 stays the same the entire time. That doesn't change the value of it, whether it's negative or positive. It stays whatever value it is, so it stays positive in this situation. But the exponent does not, so it becomes 2 to the negative 6 power. Now if we recall, when we were talking about negative exponents, when we have a negative exponent, that's telling us that we need to reverse its situation, whether it's on top to start out with. We would flip it to the bottom. If it's on bottom, then we would flip it to the top. So in this case, when we don't have a denominator, we automatically assume that denominator is 1. And we would flip the 2 to the 6th power to the bottom. It would then make it 1 over 2 to the 6th power as the final answer. Again, unless it tells you to evaluate that, that would be the answer that you're looking for. Now, if we're talking about a power of a product, now what's that mean? What that means is that if we take 2 x to the 3rd power all to the 5th power, it's saying take everything inside those parentheses to that power that's outside. So we would take the 2 to the 5th power and the x to the 5th power. Now the x is already to the 3rd power, so we follow the rule of a power to a power. So we have 2 to the 5th power times x to the 3 times 5 power. Now what that says is we would multiply 2 by itself 5 times, and we would multiply 3 times 5 for the x power. So that gives us 32x to the 15th power. Another example, if I'm given 3x to the 6th, y to the 3rd, all to the 3rd power, that would be 3 to the 3rd power times x to the 6th times 3 times y to the 3 times 3. So again, that just means 3 times 3 times 3, which is 27. X to the 18th, because we need to multiply that 6 times 3. Y to the 9th, because we multiplied the 3 times 3. So our final answer is 27, x to the 18th, y to the 9th. A good example of where we would use some of this information in the real world context, volume of a cube. If your cube is given the value of 2x, y to the 5th, on all sides, so meaning it's an actual cube, so all sides are going to be equal. 2x, y to the 5th would then be to the 3rd power, because we would do volume represents length times width times height. So that would just be to the 3rd power, which means 2x, y to the 5th would all be taken to that 3rd power, so 2 to the 3rd power times x. Now x, because it has no variable, because it has no exponent, you would take 1 times 3, because anytime it doesn't have an exponent, it's always to the power of 1. So 1 times 3, or you could simply just put 3 there. Times y to the 5 times 3. So 2 to the 3rd power is 8. X to the 1st power times 3 is x to the 3rd power. And y to the 5th power times 3 is y to the 15th. So our final answer is 8, x to the 3rd, y to the 15th. Another example to kind of establish some negative exponent values, if we have 3x to the negative 2, y to the fourth, all to the second power, we would take 3 to the second power times x to the negative 2 times 2 times y to the 4 times 2 power. So 3 to the second power is just 3 times 3, which is 9. X to the negative 2 times 2 power is the negative fourth power, and y to the 4 times 2 power is to the 8th power. So what we're looking at right here is 9x to the negative fourth, y to the 8th. But our problem is we cannot have a negative exponent, and if we can't have a negative exponent, we have to take care of that by flipping its location. Since we don't have a denominator in this situation, the entire piece is a numerator, so we're just going to flip what needs to move, which is the only thing that has a negative exponent. In this case is the x to the negative fourth power. So 9y to the 8th power is all going to stay on top and be in the numerator. And then x to the fourth power will move to the bottom and become the denominator to get rid of that negative exponent. So your final answer would be 9y to the 8th power over x to the fourth power.